Okay, sa lesson na to, pag-aaralan natin yung normal distribution. Specifically, the objectives of today's lesson are the following. First, illustrate the standard normal distribution. Second, identify the properties of a standard normal distribution. Third, find the area under the normal curve. Compute probabilities using the standard normal table, and solve problems involving normal distributions. So, ang normal distribution is the most widely known and used of all probability distributions because the normal distribution approximates many natural phenomena so well. It has developed into a standard of reference for many probability problems. Normal distribution is the reference, one of the reference in identifying the statistical tools to be used in your research. Okay, so here are the properties of normal distribution. Number 1, the distribution curve is bell-shaped. Okay. Number 2, the curve is symmetrical about its center. Meaning to say, from the center, the left portion of the curve is just the mirror image of the right portion of the curve. Number 3, the mean, median, and mode coincide at the center. This means that these three measures of central tendency are equal and located at the center of the normal curve. Number 4, the width of the curve is determined by the standard deviation of the distribution. And number 5, the tails of the curve flatten out indefinitely along the horizontal axis, always approaching the axis but never touching it, which means that the curve is asymptotic to the baseline. Meaning to say, the normal curve keeps on approaching the axis, the horizontal axis, but it will never touch because it is asymptotic to the baseline. And lastly, the area under the curve is 1 or 100% in percentage. So from the center, the left portion, ang area ng region na yon is 50% and the other one is 50%, yung sa right portion. So, why is the normal distribution useful? Because number 1, most things are approximately normally distributed. Like the height and intelligence. They are normally distributed. Number 2, the normal distribution is easy to work with mathematically. And number 3, there is a very strong connection between the size of a sample n and the extent to which a sampling distribution approaches the normal form. Many sampling distributions based on large n can be approximated by the normal distribution even though the population distribution itself is definitely not normal. Number 3 is something to do with the central limit theorem. And central limit theorem is used to determine the sample size when you are doing your research. Okay, so in this lesson, we are going to talk about the standard normal curve. A standard normal curve is a normal probability distribution that has a mean of 0 and a standard deviation 1. So at the center is the mean and one standard deviation from the left and from the right, or to the left and to the right, it is approximately 68.2% of the normal curve. And two standard deviations left and right, approximately 95.4% of the normal curve. And three standard deviations from left and right is approximately 99.7%, or more or less 100%. So that's why ang standard normal curve natin, the area, are from negative 3 up to 3 standard deviations is approximately 100%. Okay, so since the raw score cannot be plotted in the standard normal curve, it should be converted to z-score. So the z-score describes the position of a raw score in terms of its distance from the mean when measured in standard deviation units. The z-score is positive if the value lies above the mean, negative if it lies below the mean. Okay, this is the formula to find the z-score. Z equals X, the raw score, minus the population mean divided by standard deviation. So say for example, given the mean equals 50 and the standard deviation of 4, find the z-score that corresponds to score x equals 58. Using the formula, z equals x minus mean divided by standard deviation. Just substitute all the given. So the raw score is 58 minus the mean 50 divided by standard deviation of 4. 58 minus 50 is 8 divided by 4, 2. So the z-score is 2, meaning to say the raw score of 58 is 2 units above the mean, or 2 standard deviation units above the mean. Okay, is it correct? Because 50, when you add 4, so you have 54, 1 standard deviation, and add the additional 4, 54 plus 4, 58. So this is 2 standard deviations. So our main concern here is about the area under the normal curve. We know that the area under the normal curve is 1. It represents the probability or proportion or the percentage associated with a specific set of measurement values. So probability, proportion, and percentage are the same. So let's have an example. Using the z-table, find the area that corresponds to the following. Z equals 1.96. Remember that the mean, the middle portion of the normal curve is the mean, which is equal to 0. So when we are looking for z equals 1.96, it is the area between 0 and 1.96. And it can be located easily in our z-table. So we have 1.9, then additional 6, so 1.96. So the area under the curve is 0.4750. That's it. Number 2, what if z equals negative 2.18? So since symmetric with respect to the center yung ating normal curve, so kahit positive yung nasa z-table, same din lang siya sa left side because they are symmetrical. So 2.18, so we have the area from 0 to negative 2.18. So sa left side lang ng 0. So 2.1 up to 8. So the area is 0.4854. That's the area of the normal curve. It is also the probability when z is negative 2.18. Let's say how this. Find the area under the normal curve to the left of z equals 1.52. To the left. So ang ating 1.52 nasa right side ng 0 and it is to the left, meaning to say all values less than 1.52. So i-shade natin lahat ng yon. So what will be the area of this? We know that the left side portion, ang area niya is 0.5 plus the area from 0 to 1.52 is 0.4357. So we will add 0.5 plus 0.4357 is 0.9357. So this is the area under the curve to the left of z equals 1.52, or probability that z is less than 1.52. How about this area between negative 1.36 and 2.14? So negative 1.36 is located at the left side of 0 and 2.14 is nasa right side. So we know that from 0 to 1.36, ang area niya is 0.4131 and the area from 0 to 2.14 is 0.4838. So i-add lang natin yon. So 0.41 plus 0.4838 is equal to 0.8969. So this is the area between z equals negative 1.36 and z equals 2.14. Okay, next. How about z greater than 1.52? So from 1.52, since greater than, ang shade natin, papunta lahat sa right side, more than 1.52. Okay, how we are going to do that? We know that the area from 0 to 1.52 is located in the normal curve, which is 0.4357. And we know that the area of this portion, the half portion, is 0.5. So we will subtract 0.5 dun sa 0.4357. So ang difference is 0.0643. So this is the area to the right of z equals 1.52. let us apply this in a problem. So, example, consider the intelligence quotient scores for people. The IQ scores are normally distributed with a mean of 100 and standard deviation of 16. If a person is picked at random, what is the probability that his or her IQ is between 100 and 115? Okay, sabi dun sa problem, probability that the IQ is between 100 and 115. The given are raw scores. So, first we have to convert it to z-score. Given na yung ating mean 100 and our standard deviation 16 and the two raw scores. So, we're getting probability that x is greater than 110 and less than 115. First, i-convert natin yung dalawang raw scores sa z-score using this formula. So, when x is 100, by substitution, x is 100 minus the mean of 100 divided by standard deviation of 16. 100 minus 100 is 0 divided 16, 0. And if x is 115, so 115 minus 100 is 15 divided by 16, 0.94. So our raw scores are 0 and 0.94. So we are getting the probability from 0 to 0.94. So since the left portion is 0, we can directly get this from our normal curve. So the probability to the right of between 0 and 0.94 is 0.3264. So this is the probability that the IQ is between 110 and 115, or in percentage it is 32.64. And last example, according to the Federal Highway Administration's 2006 Highway Statistics, the distribution of ages for licensed drivers has a mean of 47.5 years and a standard deviation of 16.6 years, assuming that the distribution of ages is normally distributed. What percentage of the drivers are older than 21 years of age? So the mean is 47.5, standard deviation is 16.6, and the given raw score is 21 years. Okay, we are looking for the probability that the age is greater than 21. Kasi sabi doon, older than 21. So first, we have to convert 21 to z-score. So by substitution, so we have 21 minus 47.5 divided by 16.6 is negative 26.5 over 16.6, which is approximately equal to negative 1.60. So we are looking for the probability that z is greater than negative 1.60 because it is older, sabi dun. So greater than negative 1.60. So we know that the right portion, ang area na nun is 0.5. And another from negative 1.60 to 0, yan yung area sa normal curve ng z equals 1.60, which is 0.4452. So therefore, the area that z is greater than negative 1.60 is the sum of 0.5 and 0.4452, which is 0.9452. And since the problem is asking for the percentage of the drivers who are older 21 years of age, we'll convert the decimal to percent, which is 94.52%. So this is the probability or the percentage of the drivers who are older than 20 years of age.